This is the key to the worksheet on the average rate of change topic. Now, number 1 and 2, you're given functions, algebraic functions, and in numbers 3 and 4, you're actually given the graph of the functions. But in 1 and 2, let's talk about how to do 1 and 2. So you want to find the average rate of change of the function, of this quadratic function, in the interval -2 to 3. And remember, that's where we talked about the average rate of change being the slope of the segment that joins the points where x is -2 and where x is 3 on this function. So basically, in number 1, when you're finding the average rate of change, you're basically finding the slope of the segment from x equal -2 to x equal 3 for this function. Average rate of change. So in the denominator, the way we talked about this was and let me go ahead and write it as -2 to 3. So we're going to let this be x1 and this be x2. So from x equal -2 to x equal 3. And so remember the idea that slope is rise over run. So change in y divided by change in x. When we talk about change in x, that's the difference between the x values here. So it'll be x2 minus x1. And so we talked about slope, the number that goes up here is the y value that corresponds to x2. So we have to find f of x2, and then we're going to subtract f of x1. So that's how you can find the average rate of change when an explicit function is given. And so all we do is just substitute. So in my denominator, that's pretty easy. You're going to say 3 subtract -2. 3 subtract -2. And in the numerator, if x is 3, you've got to find f of 3. And then you're going to subtract. And if x is -2, you're going to have to find f of -2 and then subtract those two y values. To find f of 3, though, that's easy because you know that the function given is 2x squared minus 3x. And so to find f of 3, wherever you see the variable x, you're going to substitute 3. So I get 2 times 3 squared minus 3 times 3. Well, 3 squared is 9. 9 times 2 is 18. And then 18 minus 9 is just 9. So f of 3 is 9. So that means that that f of 3, that value I put here, is 9. So I get 9 subtract. And then I'll find f of -2. I do the same thing. So f of -2. So to find f of -2, I go to my function f, and wherever we see the variable, I substitute -2. So I get 2 times -2 squared minus 3 times -2. Well, -2 squared is 4. 4 times 2 is 8. Subtract 3 times the -2 means adding 6. So 8 plus 6 will give you 14. So then this becomes 9 minus 14 divided by, and then 3 subtract -2 means 3 plus the opposite of -2, which is 2. So 9 subtract 14 is a -5. 3 plus 2 is 5, and so I get a -1. So what I found is that in terms of the answer, the average rate of change in the interval from -2 to 3 for this function is -1. So the average rate of change is -1. All right, so there's the work, and there's your answer. That's the average rate of change. Same thing for number 2. So number 2 is just a different function right here. Different function. You do the same thing though. So number 2, so remember the average rate of change is basically you're finding the slope of the segment that goes from the point where x is 4 to the point where x is 25. And so the average rate of change I'm going to go and write the interval. So the interval was 4 to 25. And my function g of x is 3x plus the square root of x. All right, so you're going to so the denominator will be 25 minus 4, and the numerator. So the numerator you need to put the y value here that corresponds to the x 25 and the y value that corresponds to 4. So it'll be g of 25 minus g of 4. And we just have to go on the side and figure out what g of 25 is. Well, g of 25, so my function g of x, I'm going to substitute 25 where I see x. So I get 3 times 25 plus the square root of 25. So that's 75, and then the square root of 25 is 5, so I get 80. So this number right here, this value right here is 80. So I get 80, subtract, and then we do the same thing for g of 4. So g of 4 will be 3 times 4, so 3 times x, so x is 4, plus the square root of 4. So that's 12 plus 2, which is 14. So I get 80 minus 14 divided by, and then 25 minus 4 is 21. So 80 minus 14 is 66 divided by 21, but reduced. 66 divided by 21, they're both divisible by 3. So that's 66 divided by 3 is 22. 21 divided by 3 is 7. So there's your average rate of change. So the average rate of change, and leave it as a fraction. Don't change it to a decimal. The average rate of change for this function here in that interval from 4 to 25 is 22 sevenths. All right, so that's number 2. All right, then number 3, you're given a graph. So let me see if I can extend that a little bit bigger. So let's see. All right, so you're given a graph, and you want to find the average rate of change of this function here from the interval 2 to 12. So for that one, it helps, since the graph is given, it helps to actually pinpoint where the points are that corresponds to 2. So when x is 2, here's the point that corresponds to 2 right here. See that? And then when x is 12, here's the point that corresponds to x equal 12. Now let's go ahead and label those points. So this point here is 12, 9. See that? 12, 9. And then this point here is 2, 4. And just like we talked about before, so the average rate of change of this function is the slope of the segment that joins those 2 points. So basically just finding that slope, the slope of the segment joining this point and this point. So the average rate of change will equal, all right, so you just subtract your x coordinates. It's going to say 12 minus 2. Now remember we talked about earlier, so the value here that goes first is the y value that corresponds to x equal 12. Well, when x is 12, my y value is 9. Subtract, and then what goes here is the y value that corresponds to x equal 2. So the y value that corresponds to x equal 2 is 4. So I get 9 minus 4, which is 5, and then 12 minus 2, which is 10, and then when I reduce, that's 1/2. So the average rate of change is 1/2. And notice you see that the average rate of change is positive, right? So it should be positive because if you notice when I go from 2 to 12, this segment's increasing, so the slope should be positive. So the average rate of change is going to be 1/2. All right, and let's look at this one. So now we have this function here. And so just like we did the previous one, let's go ahead and locate those points for when x is 1 and x is 7. So when x is 1, here's my point right here. And when x is 7, here's the point right here. And notice if I connect those 2 points, that segment is decreasing, right? So that segment's decreasing. So it means that when I find my average rate of change, that number should be negative. All right, so let's go ahead and label those points. So this point here is 7, 3. And then this point here is 1, 5. And so in the denominator, that's easy. You're just subtracting those x coordinates. So 7 subtract 1. And then the y value that corresponds to 7 must go first. So when x is 7, my y value is 3. Subtract. And then when x is 1, my y value is 5. Well, 3 subtract 5 is a negative 2. 7 subtract 1 is 6. And then when I reduce, this becomes negative 1/3. And notice it is negative. And so the average, or it is decreasing, the average rate of change for this function from x equal 1 to x equals 7. So all these y values per unit. So from 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, each of those y values are changing on average by 1/3. And the same thing here, from 2 to 3, 3 to 4, 4 to 5, 5 to 6, the average rate of change for each of those from 2 to 3, 3 to 4, and so on, the average y value is changing by a half. Now, see how some of this is positive, some of this is negative, some of this is positive, but when you look at all of them together, the average is 1/2. Same thing here. See how you're going down? So the average y value is changing, is decreasing. Here it's increasing, here it's decreasing. But taking all together, the average is a negative 1/3. All right, so that is the key to the worksheet on average rate of change.